What's going on YouTube? Bryce builds it all. I don't like this light. Hang on a second. That's better. What's going on YouTube? Bryce builds it all, your favorite AMPIA Part 147 instructor, back with another video. This time I'm going to be talking about how to use a voltmeter. Now, I realize it's been a couple weeks since I uploaded a video related to aircraft. So if you're new to the channel, I have been filming a series for AMP students or aircraft mechanics students looking or preparing to go test for their oral and practical test to get their AMP certificate. And this video is going to serve as a practical demonstration. Again, I'm going to showing you some tips and tricks on how to use a multimeter, some of the different functions of whatnot. And I'm finally going to pull down one of those boxes that you'll see behind me so often in my videos to demonstrate this for you, how to use a voltmeter, how to make sure you're getting the proper readings and whatnot. If you're not an aircraft mechanic and you're just curious, how to use an ohm meter or a multimeter, I should say, then this video might serve to help you. So as always, stick around. Okay, this box can be quite daunting to look at, and there's a lot on it. So I've actually taken it down to its basic elements. And what I have here is to simulate my battery. I have ground, I have my voltage, and if I look down here, I have my ground on this side, my voltage on this side, with a resistor in between. That's 100 ohm. The other configuration that I can do is I can go from the positive to the resistor, and then I can move this one here, and I can take this jumper and I can go from there to here, right? So now the power is coming from here, it's going through this wire, it's going through the first resistor, coming through the second wire, going through the second resistor, and then to ground. I've also got a light down here so I can unplug it completely, and I can instead plug it into this light. So now I'm going from the battery through the first resistor, through the light, and then into ground. There's no switch, there's no on-off. It's just a simple circuit. So with that being said, let's talk about troubleshooting power. And first, I want to talk to you about voltage. Now, voltage is far from the hardest reading, and I'm going to do this as best I can. But this multimeter is fortunately automatic. So when I put it on voltage DC, it will automatically read voltage, but not all of them are. You may have a range selector. It'll say 2 volts, 20 volts, 200 volts, and so on. Now, you need to make sure that your leads are in the right terminals. This one is in ground. This one is over here for voltage and ohms. This one is only used if I'm reading amps. So right now I'm reading voltage. Now, if I take my leads, and I'm going to do my best to try to hold the ground lead in my hand. So let me just go from the ground side of this circuit to the voltage supply. I will get about 8 volts. Well, I'm supposed to get 8 volts, but I'm not getting 8. Oh, it'd help if I turned it on. Silly. I will get about 8 volts, and that's what this box is set up to run. It's set up to run 8 volts. I can lower the voltage with the supply by doing this, but I'm just going to keep it turned right up at 8 volts where I want it because I'm going to make a point. So I'm reading the total voltage drop across the DC circuit, and there's nothing parallel. This is all series, so the total voltage drop is all 8 volts. Well, if I take my red lead and I move it from the battery, and instead I move it to the second resistor, you'll notice it now only reads 4 volts. That's interesting. If I take the voltage drop across the resistor, which is basically what I did, I read 4 volts. If I read the voltage drop across the first resistor, it's 4 volts. And since the total circuit voltage is 8 volts and I drop all of it, I drop 4, I'm gonna zoom down here, I drop 4 volts across the first resistor, I drop 4 volts across the second resistor for a total of 8 volts. If I unplug this and I now go to this configuration, so I'm going to take the second resistor out, and now my circuit only has 1 resistor. There's 1 resistor in the circuit. That's a pretty boring circuit. There's not a lot going on. If I take the voltage drop across the 1 resistor, it's going to be, and I'm trying to do this where you can see it, it's going to be 8 volts because the total voltage will drop across the 1 resistor, and we could figure out how many amps are flowing through that resistor through Ohm's law. But this isn't about calculating Ohm's law. This is about using a meter. So the important thing with a voltmeter, let me go ahead and move this back to how I had it. The important thing about a voltmeter is that when you're reading with a voltmeter, you are reading the voltage drop across whatever you are checking. So you're really just checking for power when you're doing voltage checks. And I should preface this by saying, actually I'm going to make an editorial note. I use my voltmeter for troubleshooting and reference. I am not using my voltmeter in an aircraft to actually perform system tests or to determine airworthiness. And that's important. If you are using it to determine airworthiness, meaning you're actually testing outputs and whatnot, then you should probably have that meter calibrated. But if you're just using it for troubleshooting purposes to figure out why the circuit's not working or why it's not doing what it's doing, then you'll probably be okay with just using it for reference. But you probably want to put like for reference only on it, or not calibrated, used for reference only, so that people know I'm not using this for calibrated purposes. I'm not doing this to do testing of the system. I'm just using it to help determine what might be causing this light not to come on or whatever it may be. So anyways, back to the video. So I say that for a reason. If you're doing voltage checks all throughout this thing and you got your ground set up and you're doing the voltage here, it'll be 8 volts. Here it'll be 4 volts, here it'll be 4 volts, and so on and so forth. And you're thinking, man, the voltage isn't right. Well, again, you might be losing voltage through any resistors that are in the circuit. If it's series, you don't know if that circuit is parallel. It just depends on what's going on. But voltage checks, that can get you. If you're looking to just see if you have 8 volts, that would be the same as checking from the positive to the negative terminal of the battery. You should get 8 volts when you do that. Voltage, pretty straightforward, but not really any risk of smoking your meter. So now let's talk about this guy. Let's talk about ohms. Now, when I'm checking ohms, it is absolutely crucial that your system is de-energized. Your system is de-energized. If you do not take power away when you connect your ohm meter, you'll see I now have my meter set on ohms. When you connect your ohm meter to take a reading, you will be letting all of the magic smoke in this meter that makes it work out. And once you let the magic smoke out, the meter doesn't work anymore and you have to get a new one. So we don't want to let the magic smoke out of it. We need to make sure we take the power off, which on the box, I've already turned power off. And I'm now going to go whoop, right up to the resistor. And again, I'm going to try to hold this ohm meter where you can see it. Let me check the first resistor. And I get 99.1. So I know it's about 100, so that sounds about right to me. Check the next one, and I get 98.9, so 99, so call it 100 on that one as well. So I know these 100 ohm resistors are doing resistance, but part of the reason that you might do an ohm check or a continuity check is if I took this resistor out and instead my circuit had just a light in it. So now that I've got a light going on, let me go ahead and turn the power supply on, and you can see this light lights up. If I turn it off, the light goes away. Now if I do my ohm meter, and I'm going to go ahead and put it to continuity, so I'm no longer checking ohms, I'm listening for a tone. If I do this, yay, okay, and I put my leads across this light, I should get a reading on the meter. Sometimes it'll sound, it's not. I'm getting about 30 ohms through that light bulb, so now I know that's a 30 ohm light bulb. Isn't that special? But the point of this is to say that if I want to check this light bulb, or let's say that light bulb was this resistor, if I want to check this resistor for continuity, or this wire for continuity, whatever it may be from continuity, you need to isolate it from the system. You need to break it from the system completely, because when you're checking for continuity, that continuity could be finding its way through the circuit elsewhere. Now this circuit just has a 100 ohm resistor in it, and then it goes back to the battery. But if it was perhaps in parallel, if it had a second ground in that circuit for whatever reason, then that continuity could find its way back without going through this resistor, or in this case when I'm talking about a light. And if you have your leads here and you're trying to read continuity across that, you might be getting continuity even though the light bulb, which this is a resistor, but you might be getting continuity even though the light bulb is burned out. So when you want to do continuity checks to determine airworthiness, what you'd have to do is disconnect one side of the light bulb just to make sure that you're doing good, and then check continuity across the light bulb. And I'm getting, again, 30 ohms because it wasn't burned out. But you need to make sure that you're isolated so that you determine, okay, this light bulb is good. And I know the light bulb's good because it's working. If it wasn't good, it would be burned out. More than likely in a light circuit, the light is usually what's going on. You can do the same thing for grounds. You can check continuity from ground to ground. You can't see the grounds. I've got the grounds going on up here, but ground to ground, I should get continuity if I go to continuity. And all I'm doing is checking from this ground pin to this ground pin. Now, why that's important and why I say that, don't always just trust a continuity check. Let's say there was a whole bunch of corrosion on the end of this and I have it plugged in here. I might get continuity like you hear, but there may be enough corrosion on this terminal that a continuity check or an ohm check is not going to show up. But again, the important thing with ohms is to make sure that you're breaking the system so that you're not finding continuity back through that circuit. Last things last, let's go ahead and look at amps. Now, when checking for amps, you have to do something completely different. And with this ohm meter, its upper limit is 10 amps. You cannot check for amps with this ohm meter over 10 amps. If the circuit is over 10 amps, you need to grab a different ohm meter. I've seen them as low as 2.5. My personal meter is 5. This is actually not my meter. This is someone else's. My personal meter is 5 amps. But I very rarely ever check amps with it. But it might be something you have to do at your O&P. So again, I'm going to put the red lead on this wire, and I'm going to pull it out and hold it in my hand like this so that I've got good continuity. And then I'm going to take the black lead here, and it's got 0.3 milliamps, so not that much. If I take it away, you see the amps go away, bring it back. There's the 0.3 again, or 0.03, I should say, again. And that's very important with amp meters. Amp meters will only work if they are in series. Now, I'm talking about this amp meter. I realize there are digital amp meters and things that are designed and operate based off of a shunt, which is basically just a resistor, and then this is essentially it's an ohm meter, but that's besides the point. But for your multimeter, in order to check amperage, you need to connect the meter in series. So that can be a little difficult depending on how your system is set up, and you're going to want to make sure, again, that you're not over 10 amps when you're checking amp meters. But there you go. Those are your 3 major readings. So there you go, everybody. I kind of kept it short. I kind of kept it simple because that's exactly what a DME is going to do when you take your test for your oral and practical. He's not going to have you read like microfarads or some weird thing. He's going to have you check voltage. He's going to have you check resistance. He's going to have you check for continuity, or he's going to have you check for amps, or he might just have you explain to him what you would do. And as long as you understand that for an ohm meter, if you're checking for continuity, you should isolate whatever it is from the circuit to make sure that the light or resistor, whatever it is, isn't burned out. For amperage, it needs to be connected in series, and that for voltage, you're measuring the voltage drop across the entire circuit or whatever it is that you are doing. You should do just fine. So if you found the video helpful, as always, I ask that you leave us a like, leave us a comment, subscribe. Tell me down below what you'd like to see next. I've done a whole playlist on these, so make sure you check out that playlist on practical project demonstrations. It's attached somewhere at the end of this video. So check that before you suggest something. Make sure I haven't already done it. I've done like a bunch of videos on safety wire, and I always ask people like, oh, do safety wire. I've done safety wire a bunch of times. But if there's something you want to see, make sure you drop it down below. If you found this helpful, leave us a like, all that good stuff. As always, go build something and be easy.